Okay, so I hope all of you are okay this morning. So this morning, we are going to uh, formulate uh, how to design a reinforced concrete beam. Okay, in previous meeting, I just give you an idea why there is a reinforced concrete. Okay, so the reason is that concrete is not uh, strong in tension. It is only uh, good when you have a compressive force. But even though it has limited compressive force, but it is a lot stronger. Okay. So therefore, we need to reinforce the concrete when there is tension. But we extend to that concept. We do not only reinforce the tension, but there is also a need to reinforce the compression to improve its performance. Okay. Reinforced concrete that is reinforced in tension only can carry a load, no? But sometimes there is earthquake, and earthquake causes vibration. When there is vibration, there is somewhat uh, reversal of stresses. So, like for example, you have a beam that is sagging and the curvature is opening upward. During vibration, it could change into opposite. So just like when you are in the middle of the bridge, when the cars are stopping due to a traffic jam, so while the vibration, it seems that you are tossed up and down. Okay, so that means that if you reinforce only in tension side, and that is typically for a simply supported beam that's at the bottom, when there is earthquake, the tension side is not tension anymore, but sometimes for a certain period of time, let us say for 1 second, it becomes compression, while the other side, which is the top side, which we thought that is compression, during the earthquake, it will become tension. And if you reinforce only for tension, so there is a cracking that will occur, or probably a failure of your section, no? Because of that stress reversal. So what is actually done in actual, the time when there is stress reversal, is we reinforce both sides, no? Tension but also compression. And in fact, during the analysis, we consider the earthquake load as our main load, and then we determine the effect. Okay, but that is in the analysis, no? The, the most probable load combination that will happen throughout the lifetime of the building. Okay, so it's not only dead load plus live load, but the dead load plus live load actually is the kuan the tawagan prevailing, no? It will prevail because of its magnitude, it is high, and also it is always there. But we cannot also avoid that there is earthquake, and sometimes in taller structure, we consider the wind. Okay, during the attack of the typhoon, a strong gust of wind will be present. So those forces have to be considered in the design, even though they are not permanently there, but we are sure they will occur, just like earthquake. Okay. So this morning, we are going to discuss, and one of the objectives this morning is to come up with a formula on how to design a beam. But we will start first with singly reinforced. We do not go to the doubly reinforced right away. No? So we need to understand. We need to do it step by step. So this morning we discuss how to design a reinforced concrete beam. That is reinforced in the tension side only as a start. Okay? But later, the ultimate formula that we will be using in the reinforced concrete beam is the doubly reinforced, of course. But we cannot, the reason is that we cannot do it right away. So we have to do it step by step. And that is starting from singly reinforced concrete beam. Okay, so that is our objective this morning. So I am going to present a window, no, wherein or document where the lecture this morning is to be recorded. Okay, so these are taken from our last lecture. No? So in actual reinforcement, you see that on the extreme sides of the beam, which is the top and the bottom, they are reinforced. Okay, and not only the main reinforcement is there, but also the shear reinforcement, which appear as a hook or a ring. No, so we call this stirrups. Okay. Now the main bar bigger in diameter, so you can visually identify them. No, they are bigger diameter, and then we are going to use deformed bar. So there is what we call deformities that appear on the surface of the reinforcing bar. Okay, this is to improve the grip or the bonding between the two materials, the concrete and the reinforcing steel. Okay, so we call the longitudinal reinforcement as the main reinforcement. Now, the next is the difference between plain and reinforced concrete. So this is about the plain. It is unreinforced. You see that, as I have mentioned to you, that the concrete is very weak in tension. Now, if you load a P here, this beam will bend. No, there is a bending here. Okay, bending, but it can bend only that much. Okay, but we know that concrete is weak in tension, so the tension side and the tension and the allowable tensile stress is very small compared to compressive stress. So just it's like glass, no? It has a short of patience. So a little tensile stress on the surface will cause to crack. So and then bending could not happen. Okay, why? Because it will crack and then propagate upward. So that is a failure. And you know, once the concrete cracks, it is always cracked. But It can be repaired, no? But repairing, retrofitting of concrete, restoration of strength is different subject, no? And it's not tackled here. Okay. So the difference between the reinforced concrete is that reinforced concrete, if it is being loaded, so it could bend like this. Okay. And crack will just happen without causing failure like on the top figure. Okay. So the reinforce is very important. So the figure here is reinforced in on the tension side only because we know that tension happens on the bottom for this particular load. But when there is earthquake, maybe this one could change, no? Because there is what we call vibration. So and vibration can cause up and down movement. And not only that, it could sway also. So columns can, sometimes it will sway left and right. Okay. So we consider this our figure for the tawag na to na single reinforced concrete beam. Okay? So for a single reinforced concrete beam, your beam will bend like this, no? And we consider this beam. Okay? And then if we are going to make a section, so this is the width of the beam and this is the height. Okay? And then we just put the reinforcement, no, here, but sometimes we just let the symbol A sub S, meaning this is the area of steel needed, no. As of this time, we do not know that because we are still in the process of design. We do not even know the width in the first time, so we just put it as width. Okay. Now the depth of concrete is basically this is the depth, no. As we have mentioned in the previous meeting, the depth is from the compressive fiber to the centroid of the steel area, no? Steel area of the tension. So, I'm going to label it. Okay, I will make a dimension here. Okay, so this will be the D, no? That will be the D. Okay, wala siya gitawag og D. Okay, D is the depth of beam, D. So this is the D that is being used in the formula. Okay, so if the bending is like this, we know that the bottom is tension. That is what placed at the bottom. No, now in our configuration. Here, it is assumed that the tension side is the bottom. Okay. So, if you are going to determine the strain, you have compressive strain on the upper side. Now, see here, because and on the bottom, that is EY, meaning it refers to the steel, meaning that not consider concrete, the tension strain of concrete. Why it is? So the only material that is strained here is the steel. Okay, so that's why it is EY. Okay, EY stands for the yield strength. The yield strength. EC, sometimes this is ECU, is also the yield strength. So sometimes this is ECE. Okay, EC. We will put that as ES. Okay. So anyway, in our formula here, EU refers to EC, and the ES equals to EY. Okay. So that is what happened. Okay. Now, in the row balance, when we have a balance steel ratio, when the both the concrete reach its yield strain, which is 0.003, and the steel, which is the strain in steel, which is yield strain. So this is the equation, no? So we find the solution for C in one in okay. So uh, if this is the figure, our formula will become like this, no? Will become like this. I will set aside that one. So by ratio and proportions, C is equal to EU. C C over EU. C over EU. Okay. Meaning is equal to, this will be a subscript, and this could be a Greek letter epsilon. Okay. So C over EU is, you have this C and EU is equal to triangle like this. Okay. So if we are going to add EU and ES, it will become this side, no? It will become this one. So this one could become EY plus EU. Okay. EY plus EU. Okay. We are not going to use ES anymore because we assume it will yield. So I'll put that as a subscript. This one is also subscript. Okay, and this one will become Greek letter. And this one also is a Greek letter. Okay. So if you add the two, so this one will become the full height, no? This one will become the full height here. So may tabuan na niya is it will become insert this will become D. Yeah. Because we assume this one as D, no? This one the whole length here as D. From the top fiber to the line where your steel is, no? So this portion is the D. From here up to there, that is the D. Okay, that's the D. So I made that spread here. Okay. So we have two triangles, which are the same. C over EU, the small one. Okay. And the bigger one, no? If you do a line here, so you move EU here. So this horizontal line here is it become EY plus EU. Well, total height is D. So therefore, this one is equal to D divided by EY plus EU. Okay. So the expression are the same. Okay. The expression are the same. We call that similar triangle. Okay, similar. That's the reasoning is similar triangle. Okay, the similar triangle. Okay, I will put here by similar using similar triangle. Similar triangle. Okay. The expression C over EU is equals to D plus EY plus EU. Okay. So that is the case, no? So now we have to put an equation about EY, that EY is equal to if Y divided by E. Okay, that's the EY. That the yield strain is proportional to stress. Your stress, so it's like that. No, we have a equation in physics that says stress is proportional to strain. No, so when you say stress is equal to proportional to strain, so that is F is equal to E E. So, mo na siya ang expression sa stress proportional to strain. Or, if you have an equation about E will become denominator. So, that's the reason here, no? This one is a small f. Okay, just use small f. So, the E being the strain, but, so, it means that. But is the origin of the expression, no? This is from physics. Stress is proportional to strain. Okay, stress is proportional to strain. Stress is proportional to strain. Okay, on siya. So, in equation, it becomes like this, no? Or this is already jumbled, no? With but this one is the real expression of that. Okay. Now, putting that there, you will have an equation. Okay, you have an equation like this. So, assuming EY could give you expression. Equal to, yeah, and also you put E sub U equals to 0.003, no? That's the maximum strain the concrete could ever attain. Okay, this is taken from ECI, no? This one is small e this here. Okay. So these are the two figure that we are going to put that here, no? Put that here. So equation 1, okay, I will call this equation 1, F1, and this one is equation 2. And this one is X3. Now, if we mix all equation 1, 2, and 3, we will have C divided by 0.003. 0.003. But 1 over 0.003 is 1 divided by 0.003 is okay, that is C equals to 0.03 is equal to D times EY EY is FY we'll just put it this way, you know. Copy, put that there, but we change it to 200,000. 100,000 represents the modulus of the elasticity of steel in megapascal. Okay, so here we have Fy, but we can make it fraction here. So you have Fy divided by 200, 1, 2, 3. Then on the far side, you will have 0.003, 0.003. Okay, wala siya may tabo. Now, we can actually put the 0.003 to the other side. So, this one will become 0.0003B times we will have if we will have if y, and this one is subscript. This one is also subscript. Then we have here plus. If we 2003 times 200, 123. Yeah, plus 600. 600. Then we can put the 200,000 at the outside. We can factor out 100,000. Okay. So that is the we will put back that 200,000 here. Okay, so this is now the new equation. No? What we do is we just express this into other form. We factor out the denominator 200,000. So this will change into this. Now the 200,000 is transposed to the other side, so you will have 600C is equal to D times this one. Okay, so that is the value of C, no? C. Okay. Now still ratio is defined as the ratio of still area against concrete area. Okay. So we term rho as the still ratio. That's the rho. But the rho will appear in Greek later. Rho ratio. So if we are going to use the definition above, this will become ES over EC. But EC is equal to BD only. Okay, why BD? Because we assume the D to be the distance from here up to there. So that is the effective depth height of the reinforced concrete beam. We disregard what we call the steel cover, no, which is the distance from the centroid of the reinforcing bar to the extreme tensile fiber, extreme fiber and tension. So you have D prime here. Okay, so that's why only D. Okay, this is a subscript, and this is a subscript together with this one. So if we are going to continue again, our rule will become E is over BD. We will put BD. Okay. So that is over BD, and so and if that is the case, that rho equals to rho BD, so we can have a D here, expression of D from the equation that we derived. We can have an expression of D here, D equals to 600C divided by square root of fy. Ito lang yung piyahon. So, gamay ni Kati. Okay. Now, from this, we call this equation 4. Equation 4. And this one as what we call equation 5. If we are going to substitute equation 4 to equation 5, we will have rho what is b divided by that is in denominator. Okay, we have 600 c divided by then another like that. And we can rearrange this into equation. We have this denominator will go up, will go up, so it will become like this. It will become like this. A is equal 600 divided by 600 BC. So, mauna siya ang tabo niya. 600 BC. So, now, this is already the row balance. So, we put B here. We put B. We put B. So, muna na siyang tawag na row balance. Why we call this is as a row balance? Because it is based on the fact that the two materials is strained up to its yielding stage. So the strain of concrete reaches 2.003, while the EY is already reaching its yield stress. So it becomes EY when it's divided by 200,000. So we call this as the row balance. Okay. So this is what we call the balance steel ratio. We are not actually going to, this is not really the formula, but this is the basis of making your beam under reinforced, because our objective is to make the reinforcement of our reinforced concrete beam below the maximum steel, maximum required steel. Okay, so that is the row balance. If we are going to compute, so this is the equation of the row balance. No? Row balance. This one is one. Then also, wala pa na siya. Okay, you don't have ES, FY. Row balance. We can change ES into yeah, this is the balance steel ratio, but we need another diagram, no? So in the other diagram, I will look for figure. Okay. Okay. So, since this one is already an equation of the row balance, but we still not can use it because we do not know AS. So we still have to convert that AS. Okay. Still have to convert this AS. So, this is the figure of the beam, no? So, this is the B and the D here. Now, this is the strain, where in AC it's 6.003 and AS EY. Now, the leftmost figure, we have the stress, no? Stress diagram. This one is the strain diagram. This one is the cross-section, okay? So, this is the stress diagram. So, from the stress diagram, actually, from the stress diagram, we have two forces there, no? So, one is going to the right. So, summation forces X is equal to 0. Okay. Summation forces X is basically mechanics. Okay, summation. Now, strain are not forces. So, there are only two forces here. One is going to the right, which is FYES. FYES is equal to the stress here. You have the stress is 0.85 of FC prime of C. A, that is the intensity, times A. So not, but we have to use the A instead of C, no? So FC prime is a subscript. This is the multiplier times A and the width B. So where's that? B, EB. So EB is here. This is the area where the concrete is passing. No? Only up to here. Okay. That is the area of concrete that's being compressed. So the label here is A, not C. This is A. Okay, that is A. So, point is 0.85 FC prime is the compressive stress here. 0.85 of FC prime. Why that is 0.85 of FC prime? Because this is average, no? The actual stress distribution is parabolic, actually. But we use a rectangular, so instead of using FC prime, we use the 0.85 of FC prime, but this is already the average, not the variable one. Okay, so instead of using the FC prime, we use the 0.85 of FC prime, but this is simplified by the code, become a rectangular shape. So 0.85 of FC prime, para may mo ni siyang gitawag na kuan, ana gitawag na to nga force, resultant force is ato i-multiply ang stress o area. Ang area is normal to this force, this is A and B. That's why you have it. So by this time they have the same unit. Okay, they have the same unit. Okay, so we call this equation 6. Equation 6. Okay. Now, here, we know A is equal to beta 1C. Okay, beta 1C. So, na beta. Beta is a number, 1 is a subscript. Okay, so muna siya beta 1C. So, if I am going to mix equation 6 and equation 7, I have a new equation here in terms of Fy. Okay, 0.85. This one is beta 1C. C. Okay, muna siya hitabo. O atong baliyon na siya BC. Para una gid ang B. Okay. So we call this equation A. Ayaw sa atusan ni siya patamblingon. We will put ES here. Yes. Beta 1 is a factor actually. Beta 1 is a factor. I will explain that after this. Okay, beta 1. Kay ni gamay magud ang A sa C. Nya kay C man atong gigamit din eh. So, nya ang equation sa ang stress like ingon man nga dili C ang C taas man ingon man sa zero strain nya kini siya wala man. So, kini siya nga nag-continue A dili na to mapansak dinhi unless ma-convert na to sa C. So, we need to convert A to C. So, we let them to a constant beta 1. I will explain beta 1. Beta 1 is, all I can say is that it is a function of strength of concrete. Okay, once we put it on the equation 6, we know that our equation 6 is in terms of C na. And that is compatible to equate with this, which is also in terms of C. Okay? So, we need this to answer. There is a if y at the bottom here. So, we transfer the if y so, to the bottom. And then we call this equation 8. This one is a subscript. Okay? So, if we put it there, this one to there, we put BC at the bottom. Okay. So if we equating equations sa to siya 5 tawag natin na equation kini siguro equation 6 which is the balance still ratio. So equation 6, this one is 7. This one is 8, and this one is 9. So equating equations 6 and 9. Ang may pagkuda na is we will have row balance. Then we substitute ES by, it will become 0.85. Beta 1, ato yun ang beta 1. Beta 1. This one, C prime. And this BC will go. And then pwede mo siya y 600 over y 600 over y na siya yes ang row balance equation sa row balance. Let us compare the equation to the one being derived. 25. Ito na siya equation. This one. Okay. This is the row balance that atong gihatag. So ato i-compare niya bagid siya. Examine niya. Okay. So, row balance is equals to 0.35 beta 1 FC prime. So, correct. Dahil na siya ay times ang E is 2, 6, times sa'yo pala ini. Require over BC. Ano yan? So, pag-substitute na po, ano yun siya baliktad man. Adjust. D is equal to this. D. Then, is BD. Baliktad. Baliktad. Ini sa equation 5 po sa'yo. Okay. So, sa equation 5, ausbo na ko na equation 5. Dili pa na siya equation 5. Na equation 5 yung nani dahi. Equation 5. D is equal to ES. Okay. ES over D root. Mauna siya ang equation 5 sa apply ko. Mauna siya equation 5. So, nabaliktad akong kwan. So, kung imo ni siyang i-substitute, ato na i-substitute ang D din o kining niya, mahimo na siyang not that one, baliktad na siya lagi. Mahimo na siyang 600 copy. 600 is equal to this one. Okay. And we will put that up. So we will have a row balance. So we put row balance here. So ang ES is at the bottom. So we have ES here. ES. We put what na sa ito niya? Oh yes, this is 600C dy, or D is equal to y over 600 is equal to E is D is equal to is D rho E D is there. So, row balance can be up. Let's go to equation 6. Equation 6. Correct plus there's Fy. Fy plus 600. This one is Fy going that one. Beta 1 equal is 0.55 beta 1 BC. For ES is equals to if we put this equation here, okay, equation 6 is this one, and this is the equation 6. We put equation 6 here. Okay. And we put the equation of y here. So we have this one. So we put is here. Okay, 25, beta BC cancel. So this will become only beta 1. This one will cancel. Then 600. Oh yeah, this will become basically naman dito isa at 1. So this will become like this. This one will go up. This 600 will go up. Mawala siya. Will go up. Marami siya din. 600 over. Okay. 25 is there, beta 1 is there, FC5 is there, 600 is there. Over FY. Din lang siya. Over. Okay, so this is the equation of row balance. That is one. Medyo nakuha lang po. No? So, this is the row balance. So, this is the point is that I've just derived this one. No? So, for a start. Row balance actually class is the basis, no, for ensuring your concrete is under reinforced. So the balance is still ratio. The balance is still area. The balance is still area. Area is equal to E is B. Buta na ito nag-balance ka B is equals to rho B times B. Mao na siya ang kuan. So dapat kabalo ka sa row balance. Sa row balance. Okay? And this one is a subscript. Okay. So example. Okay. What is the balance still ratio for beam having compressive strength of concrete we call that A prime of C equal to, let's say, 21 megapascal. Yield strength of steel we call that keep Y equals to, let's say, 250 megapascal. And E modulus of elasticity of E equals to 200,000 megapascal. This is equivalent to 200 dPa. Okay. If beam is 250 mm and depth is 500 mm. What is the balance steel? What is the steel area? What is the steel area? What is the steel area to have to for balance condition? Okay. So first we have an Fc prime of 21 megapascal and Fy 250 megapascal. This is capital P. Okay. So first example. Now I am going to answer the question ganihan, no? So I will save this. So okay, so ang nahitabo class karon is akong gi-derive, ako lang gi-verify ang formula sa row balance based on the strain of the section and the stress of the section. Of course, when I verify the equation, I use the principles like stress is proportional to strain. So that is from physics, and then I use also the principle of equilibrium, in which I equate the force in steel Fy times Es times the stress also in concrete, which are acting in opposite direction. So it is equated to zero, so that it's really in equilibrium. No, your beam is not moving; it will be static. Okay, so those are the things, and then some other factors like beta 1. So I am going to explain that now. I am going to Google it. Beta 1. What is beta 1? Beta 1. What is beta 1 in reinforced concrete design? Okay. Makasabot mo kasi beta lang kung butang beta 1. Enter. What is beta 1 in reinforced concrete design? Ada yun, no? Beta 1. So, ito po sa image. Okay. So, beta 1 is a factor. Okay. This one. I will just put this. So, itong lecture. So, beta 1 is this one. This is for the beta 1. Okay. So, beta 1 varies with strength of your concrete. So, if you are using, there is a namang gipag-change ni mo good, no? The actual strain is really parabolic, no? And then you are using only this much, no? This one. This one you are using. There is really a change, no? There is really a change. And you need to this one. Okay? That will be the change. I will just put. Okay? There is a change using this figure than using the exact figure, which is this one. Some formula actually uses this one, but it's really this formula. Yes. That one. Okay, tanaw na po. Wala tayo, wala. So, ayun lang. Okay. So, malimtan naman po usahay. Okay na. Okay. So, na. So, ang reason nga nung nag-apply ta og beta 1, gawas na. Nana siya sa inyong screen. Wala pa yun. Okay. So, ang reason is that ang actual mo na stress is this one, no? This one. Unya, this triangle here is represents the region nga na-compress. Mo siya na-compress. So that ang area unta dapat nga na-compress is B times C. Pero there is twist, no? So mga glisod man nga mo gamit ka o parabolic, no, sa mga tuan kay una ang papangita sa area sa parabolic lisod, no, ngita kag si formula sa parabola niya dili pag siya perfect nga parabola, oh. Nagislas pag siya sa do ganyan. So meaning ang area sa rectangle o parabola lahi ra kayo. Ang formula sa rectangle is 0.85 of B prime times A, whereas ang formula sa parabola is lisod. So okay, kanato nga makuha nato ang area sa parabola. Pero ang papangita na po sa centroid niya, no? Kay kinalan mo tag centroid ani. So karon, ang solusyon sa mga nasa mga kanato mga scientist na mga civil engineer is ilang gi usab ang parabola into a square. So this one. So nag-introduce sila og A. Kunya, ang A is not equal to C. Klaro kayo, ang A is bubo sa C. So that's why nag-introduce sila og beta. Ngayon sila nga, beta 1 is a value less than 1. But it depends on the strength of the concrete. So beta 1 is actually is a factor nag-introduce nila due to the shrinking of C into A, no? Yang C mas taas bigid ang C kaysa A. So doon na siya value nga beta 1. Ang beta 1 ang kasagaran nga value is 0.85. That is not 0.85 always. So it follows this equation. Okay? So mao ni siya ang gikuha nako sa code, no? Ako man nag-Google mo karon sa unsang value sa beta 1. So mao ni siya ang value sa beta 1, no? So sa FC prime na 17 up to 28, pwede ka magagamit og 0.85. Pero kung 28 above, dito sa mga high strength concrete, it should be lesser than 0.85 and follows this equation. Okay, follow this equation. So sa kini sa nga formula, magamit na sa nimo. You can use this if your FC prime is larger than or equal to 28. Okay. Now, for very high strength concrete, your beta 1 is 0.65. So I say a while ago that the value is 0.85. That's not always, but for most common concrete, which fall under FC prime of 17 up to 28, the value is 0.85. Now, in our problem here, the strength is, the compressive strength of concrete is 21, so it falls under letter A. So, beta 1 is 0.85. And then the unknown here is just what is the balance steel ratio. So, if we are going to answer that, we have RB is equal to, we'll use this formula. This one, kini atong bagong na derive. Itong na-derive. Okay. So, mauna siya. Okay, so all we have to do is just to install the known, no? To saan ko ano sa mga known. Known. What are the knowns? Known data. For given data, no, not really given. Just put given. Okay, table na to para electric table. Okay, but table. First is you have A prime of C. Okay, this is 21. Y 200 megapascal. Talagyan na siya. Pascal. Apelido mo yung Pascal. So, capital gina siya. And then you have the E 200. This is gigapascal, but we use the gigapascal because megapascal naman atong unit na nan. We have to be consistent also. And then lastly, sa itong formula, natin beta 1. That is 0.85. The reason why it is 0.85 because it falls under equation A. Because if C prime is 21, okay? So I will make that into gamay din yung B. Yeah, kini siya is a subscript. Pwede na din yung subscript to para lang ano ba? Palangan-langan lang yun sa lecture. Okay. So, nakatanan ang kinahanglanon para makuha nimo ang row balance. So, the row balance there is equal to kung computer na to ano ba? Kung computer na to isubli ba ni kaya na? You have 0.85 times 21. That's equals to 17.85 times 0.85 pag yun. Times 0.85 may bitawan. Equal to that. 15.1725 na lang. Times 600. Okay. May mo siyang 9,103.5. I-divide ay na to siya of 250 itway. 36.214. I-divide pag ginato ka nang naa sa sulod sa parenthesis. Kana siya, ang total nga tulod sa parenthesis is 850. Anong 850 man? Because y is 250 plus 600. So, i-divide na to siya of 850. So, therefore, doon na siya ay row balance na 0.04284. So, that is the steel ratio. Gamayor kayo na siya kay gamayor magiging ang steel kinanglanon sa reinforced concrete, no? Labi na kasi tension side atong gibuhat. So, that is the row balance, no? This is the row balance. Now, the second question actually is, what is the steel area at balance condition? Okay. You can only answer this if you have known B and D, no? So, what are the known B and D? So, we'll add here. We will add, insert rows below, insert rows below. So we'll have B here, B lagi, B aerial, then B. So this is 250 mm and the other one is 500 mm. Okay, that's a D. So you can only convert row balance into E is balance if you multiply it by BD. This is by this equation. Okay, this is the equation. Okay, so we can answer this one. We can answer that one. Okay. So, times 250 times 500. So, you have 5355 m squared. So, mauni nga kabilya ang kinanglano nimo para kuan, para balance, para balance. Okay. So, that is only to find the E is balance. Now, so that, okay, the point is, so that mahimo siyang kuan, mahimo siyang for under reinforced concrete, for under reinforced concrete, concrete section. We need ES should be less than ESD or ES at balance condition. Okay. So, karon kay na may pandemic, para maprotektahan ko no ang pandemic is we need to wear mask, wear our face shield and social distancing. Sa reinforced concrete, we have also some organization that look into the health condition of the reinforced concrete section. So that it should be, it can be so that the under reinforced concrete section can be attained if we will have ES, if we have ES less than the ES at balance condition. So we call this ES at balance condition. We'll use still area here. Still area. ES. Tapos ito dili ma-misunderstood. Should be less than the still area at balance condition. We call this ESB. So kung saan man na siya nga para ma-ensure good nga ang imong kabilyada is less than ESB. So ang code nag-ingon nga kung pagkitaon ni nga code sa internet kadyo ato sa Google. Okay, sa Google na lang tadani kay kuan. Okay, so okay, we'll type code is still maximum still area in reinforced concrete section. Okay, maximum still area in reinforced concrete section. Okay, na ECI 31883. Ako lang po na tanawon kung sakto ba niya. Paano? Ito na. Ini datang lain. Check for maximum still area. Okay, niaw. So, nag-ingon siya nga ni adinhi, no? So, check for maximum still area. So, niagin din sa code, no? So, mauni siya. Ang giingon niya. Copy. Ako ni siya ibutang din. So, mauna. Ang giingon niya, no? Ay, sususap sa tingin ko ano. Ibutangan o aerial. Okay. ECI 318B 10.3.3 ensures ductile failure by limiting the maximum allowable tension scale in a concrete section. For a singly reinforced beam, the following procedure can be used to find the maximum steel area. ES max is 0.75 of ES balance. So for ES balance is 0.FY, 0.85, F times ECB, no? So, di na ito ni Kwanon. Okay, ato na overcome. So, we have, naman dayo, maximum steel area is 0.75 of low balance times BD. Okay, mauni siya. So, I have a conclusion here. Conclusion in here. Conclusion. Okay. designing singly reinforced concrete parenthesis, parenthesis, reinforced protection only. The steel area shall not exceed ES max or maximum steel area. Maximum steel area. ES max and should not less than minimum steel area. Ang problema karon kay wala pa ta naka-kwadog ES minimum. Kaya di mo sa pwede nga pahutak na lang ka o pagamay sa kabilya, no? Para yun, mga batang hello, Chris? Hello, ay, ako pang i-on first, ako pang i-evaluate na. Sige lang, magkabot lang. Okay, so, doon na tayo kitawag o is-max, pero nakuha na nato ng is-max, kadyot na kayo. Ang key, niya is, pagkitaon lang mo ang row balance, no? Okay, na naman ko example sa ang pag-compute sa row balance, no? Panalitan. Yung kinalanong yun niya, di naging kay given. Kaya ang formula sa row balance, maumuling formula sa row balance, function man siya sa FC prime. Kanang FC prime magbitawan, kauban na sila kay ang bitawan dependent pa sa FC prime ug Fy. Kinahanglan gyud ka og strength sa duha ka material, which is the concrete and the steel. So, you can have a balanced steel ratio. Pero kung gusto nimo kuhaon ang area gid sa steel in terms of millimeter square na gyud pila gid ang total nga area sa square, is you need to know the dimension of the beam nga imong buhaton. Okay? So, i-multiply din mo ang balance sa B and D, you will get the ES balance. Pero, ang ES balance, dili na ipagamit sa ato, no? Division na siya. Ang ipagamit is, limitado lang ganita up to ES max. Ang maximum steel area is 0.75 of row balance. No? 0.75 of row balance. This is according to the American Concrete Institute 108B. Muna siya equivalent sa IETF sa COVID. No, so di man COVID still man ang reinforced concrete man sila. Doon na organization ani nga gatanaw, no, sa health sa tawag na sa kanang health aspect sa structure, no, sa structural health dai, no, sa structural health sa imong section. So diligid ka ma-overweight o sa ma-over-reinforce, so nag-set sila og 75% lang sa row balance imong area maximum. Now, so minus yung kinani. Kung may buwan nimo row balance, multiply mo 75, so makuha na nimo ang maximum steel area. Mo na imong limit, no? Muduwa na din kay kandiha nga mo gid imong maximum, so paubos na lang kag steel area. Pero dili sa ka makapahutak o paubos kay kamo sige tawag nato og minimum steel. No, this is the minimum steel. So ang minimum steel di na lang nato ni derive ato na lang siyang i-Google, no. Natay ang i-Google. So baling nabuan nato karon is nga ang ato dayang reinforcement dapat in between siya sa minimum ug maximum. Dili siya maubos sa minimum, dili siya mo lapas sa maximum. So mao na ang atong una nga conclusion karon before we target, no. So here I will type minimum steel ratio, minimum steel area in reinforced concrete. Google, find it. Minimum steel reinforcement in beam. So, ano ito sa CI, no? Minimum. Okay, CI ta, kay CI man ta. American na itong gamit. Okay? American Concrete Institute. So, I hope nga maikunan niya siya. Minimum bill enforcement, USBD, minimum. Uh-huh. Actually, na-formula din no? But this is for PSI. PSI. So, ayaw mo kuhan basta PSI, no? Yung inch pag siya. So, we will need the SI equivalent to this. Okay. So, I'll look for another website in SI. Minimum reinforcement sa SI. Okay. PDF. Okay. Minimum steel ratio. Minimum steel ratio. Reinforcement ratio. Yeah, paano magyapon yun? Minimum steel ratio. Akin na lang steel ratio, minimum steel ratio. Okay, this is a ratio. A ratio. Wow. Really, mo. In I is I. In metric system. Okay. Siya in metric system. Okay. So I hope makin siya. Ito lang sa image na lang ta. Minimum steel ratio. Minimum steel ratio. Diba? Okay. Okay. Diba? Okay, minimum still area. 7. Metric system. Ini. Minimum still area. Lisod ni taon. So, ito lang eh. Okay po. Okay, what is the equilibrium? Wala ni. Minimum still area. Tingnan ko sa dito.
and record here as well. So we got double recordings. All right, we are being recorded.
Wala gid siya kuan class kanang is equivalent anyway in English unit minimum
Back up
minimum
where my fingers are.
2 is equal to greater than or equal to insert symbol. This one. 200 divided by if y, where if y is in E is I. Okay. Kung ako siya i-convert, so minimum rule is equal to this. Okay. So 200 over fy over if y is say 250 is to 36. Over 36. I'm going to go 250. Yes, I should. What? 250 over 36. So, doon na siya factor ng 250 over 36. So, na siya 1380. 1380 over 8y. So, where y is in megapascal. Okay, because no has no unit, so kung kini mong gamiton, 200 over fy, ang fy imong gamiton is in PSI. That means ang imong kuan, ang imong fy is 36,000. No, nani si 1,000 din eh. So kung 200 divided by 36, 123 is equals to 0.005, no? For 36 psi steel, R min is equal to min equal to 0.00555. Di mo na yung string. Now, kung gamit ka o kuhan, 250, dapat maugya po niyang labas, 250. So, save din 250. Kung 250 mong gamiton, dapat po 005 ka po labas mo. So, gamiton mo is 200 over 8y is from 36,000 from 36,000 So, dapat natin 200 times 250 divided by 36, 1.3889. Okay, let's try. 1.3889 divided by 250. Okay, so this is the minimum steel ratio. Okay. So, in our conclusion, our reinforcing bar should be between the maximum and the minimum. Okay. So, this is the maximum steel area. Okay. So, this one is important, that to have to ensure that your reinforced concrete is under reinforced, your reinforcement value or your reinforcement area in the section should be between minimum and maximum. Okay, I already put the minimum here and the maximum. So it's up for the designer to choose what is the section, what is the area of steel is going to put. If the steel area is between AS min and maximum, then you are sure that your reinforced concrete section is under reinforced and that you will have a ductile failure. Because if you are going to choose the ductile and brittle failure, ductile is when you have under reinforced and brittle failure if you have over reinforced. Under reinforced is preferable. Okay, I have already explained the reason. Okay, for the time being, we will have a break. Okay, so I will save this and then share. Okay, class. We will continue. No? So we have not yet hit our target to come up with a formula, no? But at least we learned that our the steel reinforcement in the section must not exceed ES max and must not be lower than the minimum steel ratio. And both the ES max and the ES min, uh, the formula is already there. No? So uh, uh, this time we will go with the derivation of the formula or how to decide. And it's not really difficult task. Aside that so much more that we know already the limitations of the reinforcement. It should not exceed the maximum. That should be always, so that the reason is to make our reinforced concrete section under reinforced. Okay, so there should be limit of the reinforcement, not too much. It's just like uh, example. Uh, what is the example of uh, too much? No, too much reinforcement is not good. Something like that. So anything that is too much, I think, is not good. Like over you if you're doing too much, no, so it's not also good, no. So you are allowed to drink, but not too much. Okay. So the question of over enforce is too much reinforcement. So will cause brittle failure. So the code, there's an organization called ECI, or in our country we call it the NECP. This is an organization that look into the health of the structure. You see that in reinforced concrete, it should be under reinforced, and the reinforcement should not exceed the rho max, the ES max. Okay, equation is already there. Okay, so I will continue with the lecture. No? So I will go back to the page. Okay, so that's it. So we have already the maximum and minimum reinforcement equation, and in my first example, I illustrate how to compute the maximum or the balance steel ratio and the balance steel area, which are the basis for the maximum. Because if you know the balance steel ratio or balance steel area, to arrive into maximum, you just multiply it by 0.75. Okay, 0.75. So now we will proceed with I will erase this. Erase this. Okay, so design of, we will just be specific rectangular section first, no? Because the reason why I say rectangular sections is that this is common, like section used in reinforced concrete, and over rectangular section in bending, meaning is bending with tension in for met. Okay, that's this is the 1 hour objective this morning. So I will make this little bigger. Again. And then so carbon topic. Okay, so we assume a section this section. Okay, we assume that section. So this is the section. No? So the first figure is what we call the cross section. Okay, B, and you know the difference between height and D. Height is the overall dimension from top to bottom extreme, while D is from extreme compression to the centroid of the steel area. Okay, that's the difference between H and D. And the second figure that composed of the two triangles, so is what we call the strain diagram. So and somewhere in the middle is what we call the neutral axis. So they are unstressed. So there is no stress. What is stress to the maximum is the outer portion. So that's why when you build something, the first crack will appear on the outer side. Okay, why? Because that is the most heavily stressed or the most heavily strained. So maximum. Now in the maximum compression, we label it as the maximum strain of the concrete is for geometry, well, on the other side that is EY. On the third figure, you have a stress diagram. No? Now, the actual stress diagram follow this parabolic dotted curve line. This is the actual stress distribution. Okay. So, this parabolic occupies only on the compressive side, meaning that this is the area under the compression. So it should supposedly occupy the whole dimension C, but the ECI, the organization that look into the welfare of the section, revises into a rectangular. So instead of using FC prime as the maximum of the curve, it uses only 85% of FC prime, and then it's turned into a what they call rectangular. And then much more, the rectangular covers only A distance, not the whole C. Okay, so that's the problem. But the problem between A and C is solved by relating it to the figure beta 1. A is equals to beta 1 C. Okay, so if we are going to make our first equation, summation of forces x is equal to 0. That's the first equation. So I will make this into big 60 maybe. And then I will make this into a summation. Okay. So that's the okay, summation forces x. So we can have C. I will put C here. No, I will put C here. I will insert a C here. Maybe this shape is okay. And I will make that big. Just format that format. Maybe I will make that big. Maybe 3. And then color. Color black. Okay. So that is the C. That's the C. C occupies the centroid of the rectangular block. No, rectangular block. So here, we can have I will make this into area. We can have C is equal to T. Okay. So this is the C. No, C. The one represented by the arrow above. That's the C. So C is equals to 0.85 FC prime as the stress. And the area in which the stress is acting is actually E times the B times E and B. A and B. Okay, A and B. So if C prime is megapascal, A and B is in millimeter, so the product AB is millimeter squared. So the whole C will be in Newton, no? So this is the unit. Maybe I will make this like this. Insert this one. I will make like this. Okay. So C. Okay, and then C is equal to this. So the unit here, this is the unit Newton. Okay, Newton. This is the unit. And maybe I'll put this outside. Okay. This. So this is equation. Okay. Now T is equals to E is if Y. Okay. If E is in millimeter squared and if Y is in megapascal, and you know megapascal is Newton per mm squared, so the unit here is Newton. Okay. So if we equate these two, we have 0.85 of C prime is equal to E is equal. Okay, that is Y. Now, in design, so when we say design, no, in design, there are actually there are always two ways, no, two ways. Just like maybe a coin, there are two sides, no, but that analogy is different. So there are meaning that when you design actually, the method is not unique, no. You can have so many other approaches to it. Okay, just like when you want to eat something, no, either you cook or you buy ready-made food. Okay, so you cook, meaning you design your own spice, and then you come up with a food. Now, if you feel like not doing that, I just buy food and I will just check whether this spice is okay. It's not too hot, it's not too fine. So you can still get the food. Okay. So other analogy could be I want a polo, no, polo shirt. No? The approach is not unique. Either you go to tailoring, okay, buy your own clothes, no, and then you ask one of the tailor to measure your body dimension so that he can tailor. The term is tailor made it for you. Okay. Or if you don't like, since I say na the approach is not unique, it could be other approaches. You go to the department store and take some polo shirt, and then check the dimension. They are already ready to made, and then buy it if you like. So that's it. So there are two ways. One is tailored, one is RTW. In reinforced concrete, you can also tailor it. You can also tailor made the section. That means that you have to design the width, the depth, and together with the what we call area of the steel. So that is the one that you are going to look. The second approach is you just assume the D and the A is directly, and then what you get is you investigate for its strength. Pila bagi kaya niya, you know. The other one is you have to determine the B and D based on the force and the AS. No? So what I'm trying to say here is that the structure, the approach is not unique to one method only. There could be other method. Okay. So the first approach is design. So design meaning this is tailored section. Okay, meaning you're going to tailor it. So what is given? So usually the given here, given, and there are also unknowns or to be determined. To be determined. So the given is usually first you set the mu. Okay, what is mu? This is the required moment. Okay, why moment? Because we are bending. No, we are deciding bending. We separate bending from the shear. Okay, we start with bending and then do the shear. Okay, the thing is that we do it step by step, not combine bending and shear, because it will be very it will be somewhat complicated. So we take bending first, so that's why it's moment. So sometimes this is called the demand moment. Now this one is usually determined through analysis. Okay, from your beam we dimension already, like for example the length of the beam, and then the area of the beam in which it is loaded. So meaning you have already considered the load, and then with the structural software or your knowledge in theorem structures, you can analyze for the shear and the moment, even the deflection. Okay, if you are if you want, you use a software just to determine the moment, and then usually you take the, if you are using many types of load, let's say live load, dead load, earthquake load, wind load, you are going to consider a load combination. The load combination is actually set by the code. Doon na yung mga load combinations nga nasa code. Okay, mo ito yung paluhod. Kaya ang maximum load combination ang mo pwede mao imong gamiton nga inyo. Okay. So why? Because those load cases that you have considered are real loads, although some of them is not happening, but it is going to happen. No, like earthquake. There's no earthquake now, but we know that sometimes there is earthquake. There is a time that we are shaken by earthquake. There is a time that there is the wind is very strong. Okay, so those are the times that those loads are acting in the structure. Okay, so we need the immune, no immune. Okay, not only the immune, we need also the material properties. So the material properties, this is designed by the designer. So as a civil engineer, you have to set your F prime of C. So this is the compressive strength of concrete. Now this compressive strength of concrete can be designed, no? You really want to specify this, no? Compressive strength of concrete. That's why in the formula, FC prime is always there. And not only that, you need also the Fy. This is the yield stress of concrete, of steel. Yield strength or steel, yield stress of reinforcing steel. So other like modulus of elasticity, they are considered as secondary data, but still you need them. No? You can easily obtain them. Okay. In fact, it does not appear in the formula. You already use them in the one. Okay. So these are the things, no? These are the most important thing that is you need before you can start design. Okay. So you should have this. Now to be determined is if you are going to use the the tailored approach, you need to determine the B, the D, and ES. So, to be determined. So, meaning, in the first, these are not, these variables are not yet there, but you will be the one to determine this. That depends on this. Okay. Okay. So, this is number one. No? Number one. One. If you have design or design. Number two is about investigation. No? So, we will discuss that later. That is easier. Okay. This one is also easy. No? So, we have the three sections here, the three figures. One is the cross section, one is the strain diagram, and this one is the stress diagram. And we have what we call the simplified stress diagram overlay and the actual stress distribution. So, the distance between the C and to the centroid of the steel bar, this one from there. Okay, the distance of that is less than D. Okay, less than D. And since this is a rectangle over here, so the big arrow here, the C, is acting on the middle. So therefore, if this is A, it is acting on A over 2 from both sides. So meaning that this distance actually, this distance, that is D minus, yan, D yung gamay, D minus E over 2. So, E over 2, I think that is a pair, quadratic outline. This outline. Okay. Shape. Okay, ano lang, D minus A over 2 ang distance niya. Kanya, kini siya, ang lahat ni siya C. Ito na lang tayo nga C kay ito na lagi gamit, no? That is C.
Excuse me, sir. Pwede question, sir?
Yes.
Sir, ano ng C sa... Ano sa ng C sa strain diagram, sir? O ka ng centroid sa stress distribution?
That's good question, no? So, kini nga C, dili ni mao nga C, no? Kining C, klaro kayo ni siya nga distance. Kining C nga arrow, mo ni siyang force. We are actually summing up the two forces nga na arrow, kining FYE of C. Kining C is the resultant of the compressive stress in the concrete. Okay? So, kining C, mo ni siya ang 0.85 FC prime, mo ni siya ang in megapascal, mo ni siya ang stress. Times the area, tugod kay side view mo ni siya, so area yung makita, pero ang total nga area niya is mo ni siya ang area nga may go, no? Mo ni siya. Kini. Ako lang na siya i-fill. Fill ako siya o pattern lang. Pattern lang i-fill lang. So, mao na siya, no? Na area. Ako lang i-fill. Ayan. So, i-fill na siya o kanap siya. So, dili gid entire nga C. So, dili dapat maigo ang kining arrow, dili sa tunga niya. Mo dili maigo, di mo bangga siya. So, that answers the question already. C and T. This one is T.
Yes, sir. Salamat, sir.
Okay, C and T. But here we elaborated the C and T in the table. C is equals to 0.25 MC prime as the stress multiplied by the area EB, this area, A and B. Remember, not the C. So, E now, A is beta 1, beta 1 times C. And T, that is the tensile force, is equal to the area of steel times the yield stress of steel. So, that is E is Fy. No, yeah. So, equating this to C and T, it will become like this. It will become like this. Yes. Okay. So, from here, we can have A. We can have A. We can have A equal to E is Fy. Ito dali ibutang sa diagram kini siya. Okay. Okay, divided by diagram mo po na ito probably dito mo wala, no? Another closing parenthesis mo ni siya. A ni siya nagamay 0.55 of A prime of C times BC. BC na lang, no? Kaya ang A, nawala mo na. Wala tayo C. Times B na lang. So, ako lang po, ako na lang siya subscript. Muna ko na siya subscript. Subscript mo na siya. Para pwede mo wala na ako ang so, ihana na siya. 0.85 FC prime. 0.85 FC prime. Muna siya yung E. Okay. Now, we have sinabot naman nga ang ES is equal to rho over BD. Okay. We are talking about minimum, ha? We are talking about maximum. ES is what we call steel ratio. Actual steel ratio. This is not yet the minimum. We will limit later. Is equal to this. This is a subscript. And this must be symbol. Okay. So we will take this as one, equation 1. Take 1. Okay, this is the product of equation 1. This one is we'll use this one as equation 2. Okay. Putting equation 1 into equation 2, we will have A. Lagyan po na siya A. Ini siya. Ano siya, tibugan. Pero ang iis lang nato is atong butangan dani. Itong butangan dani, sumay mo na siyang rho. Rho na siya. Rho na siya. Kunya, nani siya ay D na dahil din eh. Nani siya ay D. D, niya mawala ng B. Kaya naman kay BD. Okay, so muna na siya kaw ng equation, no? Wala akong tayo nga. Okay, muna na siya equation. Rho Fy 0.55 of FC prime. Okay. So, may mo ang imong equation 1, may mo na siya ingon ani. Equation 1. Ini siya, equation 1 Japan siya. Equation 1 Japan siya. Okay. So, kung na usab. Mamuna usab. Equation 1. Okay. Equation 1. Okay. So, this one is considered as equation. Okay. Yeah. Yes. Yes.
Sir, order sa lunch. Mag-Turks na.
Ma'am,
Turks.
Turks? Persian?
Oh.
Hindi ko
Shawarma
alam.
naman. It's either shawarma wrap or shawarma bowl. Shawarma rice.
I want noodles. Shawarma. Burgani rice burger.
No, it's just Turks.
I just want Iran and
Beef or chicken? Rice or wrap?
beef rice.
Okay.
Okay, so we go back to here, no? We can also make moment here, no? Moment. But the moment here is what we call since we are talking about the section, we are talking about mu, but in n. Mn is for the nominal force, nominal, meaning the resistance of the section. Okay? The resistance of the section is equal to this. Okay, Mn is equal to, since C and T are equal, so we can have here as these two are coupled but not in line with each other. So this one is really doon na ni siya moment, no? Mo-create ni siya moment. So that moment is equal to P. We can use P or maybe C or T. C or T times the distance. Times the distance. D minus 0.5 A or 1/2 of A over 2. So that's it, no? So you can have the nominal moment. It's not only that you can sum up forces horizontal, you can have also some moment here. That's the moment. Okay? So from this, if we use T, kay asa, ginamta nga sa nasa sa duha, kay equal naman na may nagsulti sa taas nga equal sila, o C is equal to T. So we can have in here, which is equal to, maybe T ato gamiton kay sayo na, no? T. Kuan na dahil C ato gamiton C. Okay. So, natana, no? C. Okay? So, using this Mn, we can actually I'm going to use T na lang, T. Tama na sila niya, T at malikon. So, yan na to, T. Okay, T. D. So, from that, ato na siya i-write din eh. Pero atong butangan ni siya o E is Fy. Ang E is Fy ka. Umana siya, umana siya equivalent sa T. T. E is Fy D. E is Fy D. Unya, ang E is, pwede sa nato ni siyang atong i-write ang E is din eh. Para ano tayo bagong equation sa E is. Ay, sayop din eh. Baliktad. E is rho BD. Because still ratio is Roman. So, actual still area na ni still area. Okay, actual still area. So, karang E is muna siya itong gibutang dinhiya. Yeah. Pwede niya ito sa na siya ibutang rho BD sa E is. Niya ito na siya ibutang. Okay, nalapay mo na. D minus. Yan na. D ng E pag yun, which is kini. Ito pag na siya ipuli ani. Nalipid na tayo. Okay, so nalapay mo na na, no? So, if we try to simplify this, we will just use small letter m. No, small letter m, ha? It equals to Fy divided by 0.85 5 of f prime of c. So if we make this one as equation 4, and this one as equation 5, so equating x4 and 5, we will have this one. Ato sa niya i-simplify. Yan, sa niya i-simplify. Copy. Simplify. Kailangan kay division, no? Kinito, ato na siyang ibalin sa sa ba ito, ha? Sa ato sa balik sa A. Balik sa natin sa A. A. Okay. A na siya. Yan, A maum na siya. So, ato na siyang ibutang diha. Kini siya over 2. A over 2. Ito lang siya ikon. That A over 2. Na siya ibutang diha. Na siya A. Okay, niya over 2 dayan. So, ito na ito diha 2. 2 over 2. Okay. Okay. Ano na siya. So, finish niya. Maunan siya. Okay. Now, we can put this outside kining rho FYD, no? Rho FYD. So it could be like this further. So rho FYD can be put there. So you have this. So we can put 2 here. Rho is being put inside. Rho is being put inside. Yes. Okay, so mauna siya ang labas. BD nandiyan po yung Rho there. Okay, wala na siya Rho. Ang pwede rin gawa sa anin. Pwede. So, na siya ay times sa hindi naman yung mako. Ito na to. Okay. In N is equal to this. Ang T, gilisan ako gilis Fy. Given to BD. Ang A mo na siya. So, this will become into this. In N is equal to rho BD Fy times D minus rho over 2 Fy. Rho FYD over this one 2 times 0.85 over Fy prime. Let's check. Okay. Now if we include this one, and will it, so we have mn equal to this subscript. Mn will become bd squared, bd squared times root y times 1 minus 0.5 Rn. Ano siya ang labas niya? 2 okay, 5 Rn. Kini siya is superscript. Okay. We put the D outside. So, mawala na ni siya. May mo na lang na siyang 1. May kinim D din yung mawala yapon siya. Pero may mo na ni siyang square. Okay. Okay. So, if we substitute M by 0.85 of Pepsi prime equal to M, so kining Fy over 0.85 also will become secret like this. So we can have here Mn over Bd squared. Okay, we let Rn equals to Mn over Bd squared. Kaya mga lip-lip, no? So anyway, dili na pala sila balihon. Okay. So this one is equation 6. Equation 6. So we'll have our equation equal to Rn is equal to this is now what we call the formula that we need. Question 7. So this is the formula needed in designing the reinforced concrete. I will make that bigger, maybe 20. Okay, so now this is the formula. So it requires steps in designing. Design. Taylor. Ito kung term dito. Tailored section. Okay. I will make a table for the step. Okay, insert table. So maybe I'll make this step 1. Step 1. Okay. See, we have to determine mu f prime of c and fy, no? So all of that must be known. Okay. Now we have this equation actually that mu, we have this one that mu should be greater or equal to F Mn. Dapat muna na siya. Okay. So, you should have that. This one must be okay. But we are not going to hindi natin ibutang. Actually, muna ni siyang formula actually, no? Simplified one. We use this formula. Yung kayo muna substitute mo, gyapon yung mga MNB squared with kinilagod gyapon, no? This one is more generic. More generic ni siya. This one is simplified. So either of these two, equation 6 or equation 7. Okay, with that. So instead of using the inequality sign, you use equal. So use equal. So you use this symbol, okay, rather than inequality, no? Rather than that, okay, rather than that. So you use that one. So here you can get Mn equal to Mu divided by F. So that's the equation that you need. And F for binding is equal to 0.85, 0.9. That's the value of P. Okay, I'll see. Okay. So, step 2. Step 2 is, here you can also determine beta 1, no? Determine if prime, Mn, let's say Mn, beta 1. So, beta 1 is equation. Again, beta 1 is the one that relates the A and C, no? But we need that also in the calculation. Beta 1. Beta 1 is not a problem. As long as you know the ipsi prime, like this one, there are three equations A, B, and C. So, what is the value of beta 1? If your ipsi prime belongs to equation A, then automatically beta 1 is 0.85. So, the one and step 1 are just not really problematic. If Y and if C prime, you are the one to get it. The only problematic here is the mu, but before designing, you should have an analysis whether what is really the requirement. You cannot design actually if there is no need. No, then you want to design because there is a need that you want to design the beam of the building. So you should have a mu, and this mu is from the analysis from the length of the beam and from its load, no, and necessarily the load combinations. So you have to do it manually or using a computer software. So it's up for you to produce mu, and then you can convert that into Mn by just dividing it by P, because the equations say that the required moment should be less than the capacity of the beam, the factor capacity of the beam. Okay. So now, if you want Mn only, so P should be transferred to the other side, so you have mu over P. Where P is 0.9 for bending, no? For bending or moment. Okay. So this is a reduction factor. No, because ang design principle, design philosophy mong itong gigamit is similar to LRFD, but LRFD is for the steel, while for the concrete we call it as design strength method, no? Design strength method. Before, this is called the ultimate stress design, but due to the updating of the code, we term it as a strength design method. Okay. So design for strength. So that means that you should have the required strength and then design the main. So step one, all of this, you should have this, no? You should have all of this before you can proceed to step two. And the formula is either this one or this one we are going to use. Okay. Ano yung formula? No? Either this one or this one. Then I bold. Okay. So step 2 is bali ang step 1 is basically you are di mo na siyang i-satisfy ang given, no, na nakakadana. Then number 2 is to determine the BD. So with that, with this one, you can calculate the value of your Rn. Calculate the value of Rn. Ang gusto mo calculate sa Rn. Okay. You can, no? By using equation 7, using a7, and assuming value of rho. In assuming the value of rho, more to itong previous lesson ganyan as rho mean should be less than the rho and less than the R max. Okay. O na siya ang atong leksyon kaganiha. Sa gali, reason nga nung ang atong actual still ratio should be between the R max and R min. Anybody can answer that? Anybody can answer? Okay. So in such that rho min is rho max. Okay. Now, if we go the equation of rho min, okay, rho min, ano tayo rho min ganyan? Is 1. Ako na ibutang niya para magamit na siya. Min, pwede ito ibutang na ito natin. Wala akong tanan eh. Okay. And then the rho max. Akin na lang ang balance. So, muna ito yung max. Pero, punta nga natin siya 0.75. Ako na siya 5. Rho balance, kini naman siya. Kung i-multiply mo siya by 0.75, that is the rho max. So, muna siya ang value sa rho max. Take note that this rho max is a function of f prime, fy, while the rho min is only up to fy. Now, your rho is such a way that you should be in between with that. So, with the rho, you can calculate Rn using this. And also, M dahil, kumputa itong M, kaya mong M. So, makuha na nimo ang Rn, no? Makuha na nimo ang Rn. Makuha na ba? O, kung masolve na ko ang rho, nausawan ako pagkabalo nga ang rho is between rho min and rho max. Of course, solve nimo ang rho min, ug ang rho max. Then, ma-assume na yung kadro nga in between niya. Then, once you have the rho, di mo din siya apply din eh. Pero, wala po magkakabalong sa ring M. So, ato namin yung gikuan ganyan. Yung let namin actually. M is equal to F125 This is not a theory. No? It's just a simplifying variable. So, we can have M. So, we can calculate Rn, basically, knowing all of this. Now, with Rn, step 3. That's step 3. Okay. Calculate set or determine B and D using wala na ako bulay na equation 60 equation 60 determine BD using equation 60 sa ganun na siya o ang akong i-recall na equation mauna siya okay na naman kay RA na-solve na mo sa step 2 ang MA na-solve na mo sa step 1 so you can compute the value of BD squared okay BD squared and that is equal to MN divided by Rn. Solve na ba? Solve na kita eh. Okay, so assuming di niya mo after this, if you know the BD squared, di niya mo makita ang art sa ang unsa ka kuan ka creative ang civil engineer, no? Because BD squared could have so many value B and D. So he can either assume B and determine B or vice versa. You can determine that. Okay. So then finalize. Sometimes you get a value of B or D that is in decimal, no? Doon na siya mga 0.01567. So, you cannot use that as the value in design because it's very difficult to do that in the actual. So, you have to finalize the value of B and D, no? And change and recompute B and D and recalculate value, recalculate Rn. Okay. Because Rn is a function of BD squared, now you get a BD using this one. But the value of BD is too many decimal numbers after the period, after the point. So, like for example, you get a D which is 500.67810, like that. So, you do not want to use that. So, you just use, maybe I just use 500 mm. or 510 mm, no? So, because the presence of the point, decimal points, it's very difficult to put that in the plan. So you want a dimension that is much more easy to 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 farm out in the actual. So you have to finalize your BND. Usually BND are in whole number. Like if you have 500.15 mm, you just use 500 mm. If you have 265 mm B, you just use 275 or maybe 300. So that depends on you. You have to calculate RN. Okay. In calculating RN, in calculating RN, calculate also step 4. So calculate the value of your calculate the value of updated. Ma-update na sa updated row. I-update sa nimo ang row nimo. I-update nimo ang calculate the value of updated row. Updated row. And in the updated row is by just using this one, no? Or I will set a formula here for the row. The row is actually equal to this, no? Ako na lang butang nga din row, insert section. Calculate value of row using ko na lang kini. Using this one. Using ko na lang. Ano ko na lang. Using X7. So, di na siya magagawa, no? So, recalculate RN. Then recalculate the value of updated row. No? Calculate lang, updated. Calculate the updated row. So, first, you determine the RN using this one because your row here is the assumption. This is your assumed row, assuming the value of row. That is your first assumption. Okay. So, once you have the row, you should check that your row is in between row min and row max. If it is, it's okay. If it is not, then find a way na makita na ang row ni mo naagida sa sulod. Okay, calculate the M. Then with all the row Fy and the row and the M, you can calculate Rn. Okay. Then, using equation 6a, you can proportion, no? This is, you can, some CE have really the good art in proportioning the B and D. That the section is really rectangle. It be D squared. Okay. And then after that, determine step 4. Step 4. Determine PS. PS is equal to updated row using updated row. PS. Using updated PS row P. This is the updated row and this is the B. Ngayon mo nakuha, no? Mo nakuha from step 3. Then, ang number 5, step 5, determine F, M, N. So check. You just see check. This is ticking already. Check if F, M, N is greater or equal to mu. Okay. So that's the one. So how are we going to check it? Okay, we have formula for Mn. Mn using equation 6. So Mn, never kami ng equation 6. Mn is equal to this. Masolve ba na ito ang Mn? Yan, anong tayo DB, na tayo updated, na tayo M. So, puro na itong Mn. So, gamitin din na ito. Itong P nga, 0.9 for binding. So, masolve din na ito ang PMN. We'll have example right away. Huh? We'll have example. Simplified lang, no? A beam, a cantilever beam. Para simple lang. A cantilever beam is to be constructed using using a rectangular reinforced concrete section. Okay. The first sentence describes what is the structure kind. It's cantilever beam, and what is section. Okay. Okay. It is understood that it is a prismatic, no? Prismatic. So, assume the section is prismatic, meaning it has the same cross-section all throughout. If it is rectangular from the beginning, it is rectangular up to the end. So that is what we mean by prismatic. Okay. The concrete, the dead load, including its own weight, is 18 kilonewton per meter, and the live load is 8 kilonewton per meter. Material specifications is that a prime of C for the a prime of C. Light na yan. Is equal to, say, 24 megapascal, and Fy is equal to 200 gigapascal. So, what else? Ang kinanglanon. Design the reinforced concrete section. First, we are going to find a picture of a cantilever beam. So, figure. Ano ka dito sa, then we have the solution. Okay. Okay. So, okay, class, naka-derive na ta o formula, no? Naka-derive the formula. Katong equation 6, 6A of 7 is useful in design. When we see design, ato sang isgutan ang katong tailored section. Nga kita gid ang mag-design sa B, D, o AS. Okay? So, I will teach you the other approach in which given ang B of D na section, hindi mo na lang analyze. So, but to start, we want to tailor made. So, tailor na to ang section according to the strength, according to the required strength sa required moment, and then the material strength katong specify. Okay? So, yan na. So, after that, I make a step, no? I think there are 5 steps. I formulated steps. They are procedures. So, necessary para ma-arrive ka into a design. Okay? So, like number one is just determining all the data so that you can actually manipulate the equation. Like, for example, if C prime, beta prime, if you do not have those values, you cannot manipulate the equation. Okay, because the equation is dependent on those values to determine. So, you have to do that. No? Determine the MN, determine the beta 1, Fy, F prime, the value of M, so that what is the variable there used in the equation can be satisfied, and then you can have a figure. So, step 2, step 3 up to step 5. Step 5 is basically checking whether the capacity of the beam in design is greater than the required strength ni kinahanglan sa beam, because we are simply equating the demand and the capacity here. Now we are going to match them together. Now, if you are going to match them together, it should be nga mas dako-dako gyud gamay ang capacity compare sa demand. Kay mas strong gyud siya, no? That means nga kung ang imong alsahon dito si 50 kilos na dumbbell, dapat ikaw mas husgan pa ka sa 50 kilos na dumbbell para maalsa nimo, no? So, mana imong capacity katong 50 mo to ang demand. So, yan ang buto sabot. So, you should have the capacity or the resistance na makakarga ka adtong load. So, mo na karon atong baton. Now, after deriving, I go right away to the example. So, we have an example here. So, I'll present the example. So, okay. So, here we have a cantilever beam. So, I will find a figure of cantilever beam in the internet. Pwede na ako mag-drawing. Kulang pa tadanig ko ang lens da. Ako na lang butang din eh. Cantilever beam shown in the figure na lang. Shown in the figure. Or what the figure na. Because that is using a rectangular reinforced concrete section. Rectangular reinforced section with reinforced concrete with rectangular section siguro with rectangular section. You save that. Then I will go to the internet. I hope I can find. Okay. I will type here. I will type here Okay, tayo po na. Cantilever beam. Okay, cantilever beam. Ako na move yung glass. Cantilever. Cantilever. Oh yeah, may cantilever beam. Ito na sa image. Okay. Yeah, we have it. Cantilever beam. Okay, a cantilever beam is this one. Is this one. Cantilever beam. Cantilever beam. Tibog man tawag siya. Ito na rin. Tibog. Oh, okay. So this is the cantilever beam. Kita sa kuha. Nang wapo nga po. Cantilever beam. Rectangular section. Cantilever beam. Cantilever beam. Cantilever beam. Cantilever beam. Cantilever beam. Na mag-read niyo sa gibutang daan. Lalo sa ilod gibutang daan. Yan na lang. Hala na. Ini na lang natigyan. Okay. Ini na lang. Okay. Copy image. I-class. Okay, so this is the figure of cantilever beam. Okay. This is this. Okay, cantilever beam. Wala na siyang cantilever beam, no? So, butangan na to og L. Itang section and length of 3 meters. So, you will ask, asa ba niya gamito ng cantilever beam, ha? Okay, so, mangita yapon tawag sa figure sa internet. Yung kita na to yung gamit. May cantilever beam din eh. Okay. So, ang example dahil yung cantilever beam, nito sa mga leads, no? Ini. O, na siya. O, cantilever beam na. O, putod mo siya cantilever beam. Okay. So, sa solusyon na to, mag-compute ka o W, U. And that W is equals to 1 point, if you are going to follow the load combination. There is a load combination actually suggested by the kung gamito na to ang MECP, gamito na to ang MECP, that is equal to 1.2 times 1.6. Okay, so MECP. Okay, we have the load combination yeah, using the NECP actually, 203, section 203, the factor for the dead load and the live load is 1.2, 1.2, 1.2 dead load plus 1.6 live load. This is NECP section 203. So if you have a WU big load of 1.10 kilonewton, so that's equals to 1.2 times 10 and plus 1.6 kilowatt. Di ay kagkuhan kang Sunisia ka kuan kaning hitawag kaning Osminia extension. Oo, na iyan. Oy, okay ba wala na ko para mabayaran na to karon? Sige. So 1.6 times 8 times 8. So that is equal, the unit here is kilonewton per meter. So you will have 120 plus 8 times 1.6. So you have 132.8. The unit is kilonewton per meter. Okay. What does it look like here? So if I'm going to do a line here, this is your then I can even make that bigger, and that is the black. And then I'm going to attach also here the rectangle here. Okay, and then I'll fill that by pattern. Okay, so that's the support. I will make that embedded to be assumed. Okay, and then I will make this L is equals to 3 meters. 3 meters, and then you have putang pa rin natin load load here. Okay, pattern fill. I want to use that one. Maybe use color black. Okay, and then I have also here W. This is now 100. 12 plus 1.6 times 8, 24.8 kilonewton per meter. So this is 24.8. Now the moment there is like this. The moment. There is shear diagram. So kung akong i-complete ng shear diagram this is the ito lang siya yung ibig natin yung shear diagram. Okay, ito lang i-propose na siya. Okay. So you have this. The shear is equal to, this is also what we call the VU, but momentarily we do not need this. That's 24.8 times 3. This is 74.4 kilonewton. to the moment diagram. So maximum moment principal moment. This one. Okay, that's the moment, no? So in here, in is equal to maximum is at the support. You have 24.8 times 3 times 3 divided by 2. 111.6. The unit is kilonewton meter. So at the support. At the support. Max. Maximum at the support. So if we are only using one section all throughout, we will use the maximum one. Okay. If you want if you want to optimize the design, you can use lesser section near the middle because the moment here is lesser than mu here. But you have to be sure that the section here near the support can carry up to 116 kilonewton per meter. And since we are only designing one section for the whole 3 meter length of cantilever beam, then we will adapt the maximum. Okay. So maximum moment is 111.6 EN. Then we will compute right away the MN. MN is equal to mu divided by N. And that is equal to divided by 0.9. 124 kilonewton meter. Okay, this F is equal to 0.9. Okay. So we are now with this. So I am going to copy the steps. This one. I will copy it here and then I will going to put that here. So first, I have already calculated the MN. So I have an MN here. Okay, 124 MN. I have that one. Okay. So FC prime is 24 and FY, no, this is not 200 MPa, 250 MPa, so that's FY. Wrong. Save. Okay, so we have already the load. All we know have to do is what will be the size of this and what will be the reinforcement needed. Now, class, I'm going to ask you, where is the tension here? On the upper part or the lower part? Where is the tension side? At the top or at the bottom?
Bottom, sir.
Another guess. There are only two. Well, the secret is to draw the depicted structure. No, I will do the depicted structure. Shape. This one. The depicted structure of this will become like that. So where do you think the tension here? The top or the bottom?
Top, sir.
Top. So we need the reinforcement at the top. Okay? We need the reinforcement at the top. But we can still use the same formula because this formula Actually, it's derived using when we derive this, we put the reinforcement at the bottom. But here we need the top. It doesn't mean that we have to formulate again. No, we can still use the formula, but you just always put in mind that unit E is at the top. Okay? So, in step 1, the analysis is basically the step 1. You can determine the MN. No? This is really for the analysis. No? Yung design, the section, imong i-design nun ang gidakuna ni base yun sa iyang strength. Yung strength niya is gikan yun sa iyang load. No? Sa load combination yun ka nagkuha. No? So, in fact, ato pagin siyang gi-convert into MN. Instead niya, ang MU niya is 1.6. Ato pagin ikuha ang MN using the equation of the inequalities. Nga, this one. So, your required moment should be equal to 124. This is not the required, but the nominal moment needed. Okay. So first, you're going to compute the Roman, no Roman. Okay. So we will calculate using Fy. So using that Fy, so we can calculate may mo na siyang using Fy equals to 250 megapascal ay nag-MSIC. Okay, if y is equal to that 250 megapascal, so may tabuan ni 1.3889 divided by 250. So 0.0055 muna imong rumin. How about our Rumax? Okay, Rumax. Din na lang natin sampayan. Rumax. Okay? Ilagay ito itong FC prime sa itong problem. 24. Okay. So, 24 times 0.85. I-multiply pag ini mo 0.75. Multiply pag ini mo bitawan nga 0.85. Multiply dayon ni mo 600. I-divide dayon ni mo og 250. I-divide pag ini mo og 850. So ang labas 0.03672. Mao na siya ang imong Rumax. Okay, Rumax. So, ingon man nga must be middle between this. So, if I assume R equal to 0.025, pwede tayo kaya 0.025 between man siya sa 0.0055 o 0.036. Kung assume ka 0.037, hindi na nalapas na ka. So, up to 0.036, itintuwag ka. But, I choose 0.025 or even 0.03. Okay. Still, this is okay. No? So, my M, value of my M here. So, I have 250. 250 divided by 0.25 divided by 24. The value of M is 12.25. Tapos ni siya Excel actually. 90.196. Muna siyang value sa M. Now, your objective in step 2 is calculate the Rn. Okay. So Rn here can be calculated. Rn is equal to Rn is equal to. Ako unahon ang compute ang sa parenthesis, no? I have 1 minus 0.5 times 0.03 times M 12.25 90196. Okay, ang value sold sa parenthesis is 0.81614.706 times si pwede nga 250 nga times 10 sa row nga 0.03. I have a value of 6.1208 602 The unit here is megapascal. The Rn is in megapascal. Because rho has no unit, if y has megapascal, so it carries the unit of megapascal. Okay, so I have Rn. Now, I am going to step 3 because the objective of step 2 is already met. No? I have already calculated Rn. So, with the Rn, we can determine BD. Okay. Now, Mn here, Mn, itong Mn ganun na to, nakuha na to, pila to? Pila yung Mn na to, class?
124 sir.
124 kilonewton meter. Remember, the unit is 124 kilonewton meter. And we are using Newton and mm. So therefore, I will convert this into Newton mm. Okay. Muna yung mga steps nga, dili ka dito magpusid, no? So the unit here is Newton, but this one is also mm. But you have to multiply this by 1,000. Kanang 1,000 pag-convert sa kilonewton to kilonewton. So naka 1,000. Another 1,000 pag yun, 1, 2, 3 is to convert meters to millimeters. So in other words, i-multiply mo siya 1 million. O durangan mo punom ka 0. So ang unit ano niya is Newton mm already, not kilonewton meter. Okay. So you have 154 million Newton mm. Okay. Now, you have that one. So, BD squared is equal to this. Copy. BD squared is equal to Mn, which is 124, 123, 456 divided by, sige itong Rn na to. Rn. 6.6.12086029.5. The unit of 6.12095 is Newton per mm squared. So the unit here is mm to the cube. Okay, ano matabot mo kung mm to the cube? Eh, atong kanon ha. Ang mn kay Newton mm. Okay, Newton mm. Muna siya sa mn. Divided by, ang akong butang unit ha. Ako lang na siyang ikuan. Itatag sa mn is Newton mm. Divided na yun of Newton per mm squared. Okay? Mm squared. So, ang Newton, cancel na. Wala na kay problema sa Newton. So, kining mm nga nasa denominator, nga napagin sa denominator, musaka na siya. I-multiply mo sa mm, so may mo siya mm cube. So, muna karon ang resulta ng unit. Ang Newton na yun i-cancel. Okay. Nagingon man din nga, assume, either you assume B or D or vice versa. So, first I assume B equals to 200 mm, let us say. So what will be the D? So B squared is equal to D squared is equal to pila ba ng 124? 124 1, 2, 3, 4, 5, 6 divided by 6.120860295 is equal to 20. So, nakay 20,258,590.14 divided by 200. So, is equal to divided by 200 bagay nga B yung assume nakay 101,292. But that is D squared. So, we take the square root 0.5. Doon na kay D na 318.265 millimeter. Ining D ni mo nga 318. No. Di mo na siya, no? Dapat ako yung D din eh. D equals to 318 is hindi kayo ni practical, no? what I mean is, kining sobra na yung 0.265 is difficult to determine. So, you just, as you say 350. Ganyan. Or you can go 400. There's nothing will stop you. Basta kay, dili lang ka maubos sa 318. Okay? So, you can use 400 or 350. I say 350. Okay? Ang 350 is, kung ano siya, kung ang 300 mm is 12 inches, kanang 350, that is approximately 14 inches. Okay? Pero kung 318.265, pag itaon mo na sa dimension, isod kaya na, samot na ang panday nga magbuhat sa pulma. So, you have to be practical. You have to specify measurement that is not difficult to analyze or to determine or to figure out in the actual, especially that the one who is cutting the form are just carpenters. So, they cannot even, not many of them can understand technical numbers. No? So, you just give simple instruction. So, that means that you have to be simple in your specification. So, do not give specification that are mga malibog ang mag-perform o ang mag-interpret. So, kay there is a tendency nga masayop kita yung kuhan. Okay. Okay, so hello ma. No, wagi ko na talaga ma kay yaman si Pipo niya. Na-busy ko. So, oo, kay 40 mo gud ni mama kanang 40 so, apiki kay sa ako. So, mga sunod na lang siguro na o na sa mahuman ma. Pwede, oh. Pwede yapon. Oh, sige, pwede ma. O sige ma, magyapon, Jis. Oh, sige. Karon sa Sabado. Sige ma. Oh. So, Jis, okay na ng Jis. Sige ma, nasituan mo silang kuan, silang nagbantay sa imo diha si kuan, si Sina. Isa man nagbantay pa ibalik si Sina. Pati si kuan, Eugene. Sige, sila lang duha di ama kay para kuan. Sige ma'am, pwede magyapon. Ako na yung magkuhan mo, sige. Magkakuhan ko niya, ha? Sige ma'am. Lagi-lagi, oo. Dini ka ni mga, wala mo yapon ko, ano ba, naniyado, kaya din niya, uban ka, ubasad yung mga lugar, espiritu ba, na sila ikuhan. Hindi po galing, nga niya, din nga, iputan na kung dito ko kita na po yung speakers. Okay, so dini no kita ang atong art no. Pwede sad ka mag-assume ka kung mag-assume ka og another value to 50, so you'll have lesser than this. So it depends no. So this one I will really say na kung B of D is 400, so Sige mo, ako na i-finalize, no? So, use 350, use 200, use B equals 200 mm, and D equals to 350 mm. Take note that the 350 mm is just the D, not the total height. Not the total height. That's the distance from the compression fiber to the one. So, instead na magamit ka og 318.265, ayaw na, no? Kay, mo ni siyang object na masayop na yun dito sa field. No? So, niya usahay, masayop pag point, mawala ang point na, malibog yung tayo, so, may mani kay one. No? So, you have to be, your decision is really important here, no? On what B&D you are going to use. Okay? It depends on how creative you are as a civil engineer, as a designer. Okay, so then after that, since your B&D changes, instead natin 180 mo gamit, 50 mo gamit, so your RN will also change. You have to calculate RN. So here, when I calculate the RN, after penalizing BD, I have here my new RN. Okay, my new RN is RN is 124,123,456 divided by B na 200 divided by ginamong 350. Kay discord na siya, isa ko ka 350. Ang labas niya is 5.06 122,449. The unit is mega Pascal. And after that, you calculate the value of rho based on equation 7. The equation 7 no? So, known Rn, and known Fy and M, you can calculate the rho. Okay, you can calculate the rho. So, rho here. So, your new rho, ako na makita lang kong equation sa rho na para magamit na to. Ako lang ikat sa ko sa internet sa calculate sa ko sa rho. Here, formula for steel ratio in reinforced concrete. So, mana akong topic. Again, na mo ginisya formula. Ang dapat compatible siya sa author nga itong author. Okay? Ang author na ko si Wang and Salmon. No? Wang and Salmon. So, may lani mo na siya. Nga, one. Nga, unit nga, one. Lain mo ka na author. Ito sa uwang ang salmon. Lain ko. Uwang ang salmon. English and bata na lang na ito. rho, insert equation. Okay. Okay, so basically ang value sa equation is equal to to rho, no? Rho. Rho. Okay. And that's equal to doon na siya yung fraction 1 over m, but you know already the value of m, times parenthesis na yun, parenthesis. Okay? Then sa parenthesis, doon na kay 1 minus, then doon na dahil siya square root. Square root of 1 minus fraction of sa ilang 2m r n over f y f y. So mauna siyang formula okay. So mauna siyang equation actually class. Okay. 1 over m times 1 minus square root 1 2m. So, na naman kay Inda, na kay RN, so makuha na mo ang updated rule. So, your rule is equal to your rule is equal to rho is equal to okay. So now na to compute ang nasulot sa square root ha. Ang m na to actually ang value sa m is 12.25490,196. Okay? Ano siya ang m times 2 na yun, times 2 times 5.06 122.449. So, ano siya? I-divide na ito 250. Nakala na. Dayon, i-negative na ito na siya. Plus 1. Then, take the square root. Then, negative na po dayon siya. Yun na, plus 1. Divided by m, which is divided by 12.254 na 90,196. So, naka 0.023 0.02368 ang imong rule. Okay. Now, using your value of B and D, you can have ES. ES is equals to 0.02368 times 200 times 350. So, yun na kay ES equal to n squared. n squared. So, nakakadana. No? So, it times na to na siya 0.02368 times 200 times 350 na kay 1,658 mm squared. Okay, so mauna siya, no? Now, how many bars is this? How many bars is this? So, if you are going to check how many bars that you are going to refer to the area of bars per whatever diameter you are going to use. So, like for example, I am looking into this kind of table. To give you an idea, no, we are looking into this table. Okay. These are the imperial size, no? Number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10. Then we have different country, no? Along the row, we have the US, we have the Canada, we have the Europe, we have the China, Japan. So, muna mo talaga, usa pa rin nga mga kabilya nga undersize mo ni kayo. Basta hindi din China niya. Because China has different diameter. Di lagi siya mutugma kung sa nasa, no? It's really not, it's really normal nga. Not may ilang size. Because for their country, it's okay. But if you use the diameter of the other country to the other country, di lagi siya match, no? So, we are not, we are not actually producers of steel, no? So, usually ang atong mga steel manufacturer din, gagamit sila sa technology from these countries na nag-set sa mga standard. Like for example, doon na tayo mga steel manufacturing plant din sa Misamis Oriental, na sa Villanueva, Antaguluan, but they are Chinese, no? So, we expect to have a Chinese diameter, Chinese one, no? If you order from Japan, you should specify in one. No? So, you should understand that, no? So, like for example, number 2 is equivalent to 10 mm in Canada. And 10 mm in Canada has diameter of 3. So 10 mm, masiningon ka na, ang 10 mm is kuhaan ka ng muna niyang 10 m just specify that this is metric. But its diameter is 11.3. Now when you got 15 m, so 16 mm diameter. So if you are using 20 m, 19.5. So either you use US or Canada, you should be bold, no, on this specification. So, like for example, I am using 20 m Canadian, no, Canadian. So using Canadian. So if I have a 1658, using 20 m bars, reinforcing bars, 20 m. So the diameter there is equal to the diameter of 20 m bar is 19.5 mm. 19.5 mm. So that means that the area of one bar, no, area of one bar, A1, area of one bar is what's the area of a circle? Pi d squared over 4, no? So 19.5 times 19.5 times pi divided by 4. So the area is 298.6 mm squared. That's for one bar. That's for one bar. Mm squared. So if the area of a one bar, so that means that you have to use 1658 divided by 298.6 equals to 5.55 pieces. But the question is, how can I use 5.55 pieces? So if I am going to use 5, I am now using a number that is less than 1658. So the tendency there is I am going to use 6 pieces, 20 m, reinforcing bars. So when I see M, this is Canadian, Canadian. So Canadian. Oh, if you want to use US, you can use US, no? If this is how if you use US. Yeah, if I'm going to use US, I'm using number 6. Number 5, kung imperial, kung metric size siya, number 16, no? 16. So, 16, number 16 siya, metric size. That's equivalent to number 5. Ulibog ang US kay duha. Duha imperial siya o metric. Okay? You should specify that this is metric. Yang 16 nila, wala sa nakabot og 16, 15.75 ba yung diameter. Okay? Ang yang 15M, ang yang 15M sa Canada, doon na 16mm yung diameter. Hello, Art. 1650 o kuha na. 20 ka po. Kana ako, 20 ka po. Kita tataon na po. Ang na lang asa natin. Manaog ba sa niya before 3? Okay. Okay. So, class, in this example, I use Canadian. So, 20M equivalent to 19.5M diameter. No? So, that's why when calculating the area 1 bar is 290 meters squared. So, 6 pieces would satisfy the 1658. Should have been this and this. So, 6 pieces. So, my section is like this. This is my section. Design section. Design section. Okay. I will do a rectangular bar. Do not forget that your tension is at the top. Okay. So this is where you place your 200 mm. This is where you place your I'll paano ba na siya o pin. Okay. Lakuan po ginato. Okay. Then I'll put my reinforcement. Sagalin natin butahan yung reinforcement ani. Last. Okay. Ang tension is at the top. No. Na kung gusto ka og isa ra, o iisa na siya, pero mas mayo, uno mo na lang ginani mo. Unong kabuok. So, 1, copy, paste. So, na kay ulo kabuok diha. Ulo kabuok diha. Ulo kabuok diha. So, this actually symbolize the 6 bars, no? 6 bars. Yeah, ang linya ni is gikan din. Gikan diha. Copy na yun. Paste na yun. Paingon sa sintuid sa bar, no? Sintuid sa ES niya. Kaya yung ES, unang rin yung gamit sa tuba sintuid na diya napit. Na diya ang itawag nato na 350 mm. Gikan niya. Paingon din na. Paingon sa compressive side. So, na diya ang 350 mm. 350 mm. Yes. We do it one by one. So, sa aning aspect, we are designing tension reinforcement only. No? Okay. Kung atong dunganon ang compression reinforcement, mo complicate. So, there is a topic for that. So, for a start, we will design in tension only. Okay. Next meeting, we'll have compressive reinforcement as well. So, because our topic is designing reinforcement on tension side only, so we put reinforcement on the tension. But you are right, you have to put reinforcement on the compression side. But in this topic, wala siya na to siya gyakip. But kini siya, incomplete pa mo gini siya, no? Pag-design pa mo siya sa reinforcement sa tension side. Okay. And this 350 is to the centroid, no? To the centroid. Then you put allowance, no? So the minimum distance between concrete is 25. If the minimum distance between them is 25, just to allow the 25 mm man. Kaya ang atong usual nga diameter sa grabang ibutang is 20 mm, that's 3/4 crush. So kung less than 3/4, dili kaagi niya, no? So mabara. So para dili gid siya mabara, there will be no congestion in the concrete passing through the spaces between bars. So they should have ample allowance. So the minimum is in no bars shall be less than, unless you design it as bundled bar, it can be bundled, but there are rules for bundled bar, no? You do not have to bundle it without reading the rules of bundling it. So for unbundled bars, you should have enough space for the three-port aggregate to pass so that it will not create a honeycomb. What happens if you pour here and then the gravel will just block some of the concrete in passing through? So it will create a hole here or a space. Now when the concrete is dried and you strip away all the pores, then you see there are honeycombs, there are ampaw, no? So there are hollow, there are voids inside. So that is when the consultant will see that, you say, that's no good concrete, destroy that. No, I will not accept that. No, so the contractor will have to rebuild the beams. So all over because it will be rejected. No, it depends on the mind of the consultant. No, okay, so you will have at least this one is what we call the steel cover. No? Steel cover. Steel cover. So steel cover has to account for the distance between the two bars, the diameter of the bars plus the minimum steel cover. So maybe you will put here you have this 40 plus 20, so that's 60 plus 10, 70, so you'll see 80 mm, no, steel cover. So that is your D prime. D prime is the symbol for B cover, for steel cover. So that is the space. Now you can also use different. So here you just put 620 m reinforcing. That ends our design. Okay. Here we tailored the value of D, we tailored the value of D, and we tailored the number of steel bars based on number one. This one, 124 kilonewton meter. Then, so all we use in the equation here are basically we are just using 6 and 7 equation. So always, but this equation is I'm using the Wang and Salmon equation. For Winter and Nilsson, this is a little change, but in reality they are equal, they are equivalent. No, it uses different variable and different values. No, different. But if you are going to investigate it, you will find out that they are just equivalent. No? It's just a style of the author. No? So this one is the Wang and Salmon style of presenting equation and designing of reinforced concrete. Okay. So the coming up to step 4 only is my style that I narrowed it down into step 4 steps of designing. And the 4 steps are all tabulated here in the table. Okay. You can make actually we can make actually what we call this tawag naning spreadsheet template for this, no? So that ang katuwag yung figure ang imong i-change, then everything will calculate according to the formula, no? So, yun na. So, this one, this is your section. So, therefore, if you are going to determine the elevation, so the elevation, so design elevation. Design. Pero this one is not yet done, ha? So, wala pa man kayo katong compressive reinforcement, just like the concern of your other classmates kanina, no? Is right. We need the reinforcement for the compression. So, this is the beam. Then I will going to put then let us say that mauni siya ang iyang support. Okay, muna yung support. Okay. Yan, mauni siya ang 3 meters. 3 meters. So, the reinforcement is here. Ini ang reinforcement niya. Okay. So, okay, reinforcement is here. Saan siya? Niya, ang kung pagidani niya, kay, kinalan bigid ka mo kuan, upalog mga hook, no? I-hook mo gini mo na siya din no? I-hook mo siya diya. So, dili lang kayo muna yung mga pagkatao doon. Sayop ni siya, no? Kaya sa actual ni siya, doon na pa kayo mga standard ani nga paluhon. So, ang standard ani is ka ng mga hook niya, no? So, in actual, may ani pag na siya. Butang pagiging hook ani din Naka-hook po yun na siya din. That's 90 degrees hook. Okay. So, ano siya. Dili lang po kayo diha. Ang dili pa, naka-hook po yun na siya. No? Para maayo kayo ang iyang banding. No? So, mga na iyang reinforcement. So, kung matensyon ni siya, so, bisan pag mukrak na siya, dili siya mo-separate. Why? Because it's reinforced. Kung under-reinforce siya, yung mukrak siya diya, kung sa gabi kayo nga pag-bend niya, wala nila yung, hindi na siya magsaba, maulog lang dito ang beam, no? Yan na siya. Now, in actual, butangan pag-inom na siya. So, sa actual pag-inom na mo niya, hindi mo pag-inom butangan dali, no? Hindi mo pag-inom butangan of reinforcement. Pwede siya yung reinforcement niya. Pwede mo na share reinforcement. Conclusive reinforcement na tawagan na niya. So, pero, the design of this is not covered in this topic because this topic is only for the itong di ngalan din with tension reinforcement only. Okay. So, ingon ana, no? Okay, mag-break sa takadjut because I'm going to give you your activity for the laboratory. No? Wala kayo na nakaklase last to kaya nakuan ko. Hindi na last ako na lang itong gikuan kay pagdali ko nakabalik diretso. So, I will save this and post this. Then, mag-break sa class, no? Kay mag-lunch at then init lang muna ako, kadyo lang siguro just to give you. Anyway, ang example nga akong gigamit sa inyo, mo inyong buhaton karon sa inyong activity sa laboratory. No? So, I will give you the same beam, probably different given, then you are going to calculate based on the formula that we have just derived. And then either you follow the table solution that I give you na gagawa yung 4 steps or magbuhat ng inyong kaugalingon, no? Basta follow lang mo sa formula, no? So I will give you problem to do in your laboratory based on that formula. So, bali, I have to conclude what I have done in the lecture. Basically, our lecture eat up time in the laboratory. Okay. So, first, I derived the formula for minimum reinforcement and the maximum reinforcement. So, we have the minimum still ratio and the maximum still ratio, how to compute them there. Second is how to design tailored section. No? When we see tailored, the given is the moment, the material strength, yeah, those are. And then what is the unknown? The unknown is the B, the D, and the AS. Okay. So after that, I followed it up with a problem following the formula and the steps that I give you. And then we finish it just this time. Then we have a break. Then I come back. I'll give you a problem to do in there. So it will be 20 minutes break. Okay, class. I